Thank you so much for being here, and hopefully everyone is staying healthy. My name is Ray. I'm a developer advocate for Google Cloud, and very happy to be presenting today on the first Cyberland, I guess. I'm a little bummed that JavaLand didn't take place, but I'm very happy to be here, and thank you for joining me. So I love to bring some of the latest and greatest technology from Google Cloud and also open source technology like Kubernetes to developers over the world. I do work on some other open source projects as well. For example, I contribute to JHipster, and we also have a project called Spring Cloud GCP that helps you to use Google Cloud very easily with Spring and Spring Boot. Anyways, if you have any questions, you can find me on Twitter at Satanism, or you can find all of my materials and talks and workshops and collabs, sample code on my site, which is satanism.me. Aside from technology, I love to travel, and this picture is something that I took a while back when I was backpacking in Asia. Long story short, I wasn't able to find a place where I can stay, so I had to actually go out and find a free place for me to stay cheaply in this middle of nowhere in Asia. So somebody told me, well, if you don't want to pay a lot of money to stay in a hotel, you can actually go out to a desert, and once you get to the desert, you can walk for 4 hours in the southwest direction. And once you go there for about 4 hours, you're going to find a real oasis, and you can stay in the oasis for free. And I heard the word free, and I just went. I'm like, which bus do I take? How do I get there, right? But I don't know how many people here hiking the desert before, but it's pretty darn hard. It's hot, it's dry, you need to bring water. I carry everything with me, and the sand is really soft, so every step that you take, you're going to sink a little bit. And when somebody tells you to walk in one direction for 4 hours in the desert, you go over anything that's in front of you, no matter what it is. So you see all these sand dunes in the picture? Well, I had to go over them, and it's very hard and very difficult. And it really reminded me of writing the old J2EE applications back in the day. I'm like, I'm on vacation here. Why am I doing this? Right? But long story short, the end was absolutely beautiful, right? This is where we all want to get to, which is production, right? This is the beautiful place where we all want to get to, but the road to production is not so easy. There are so many hardships that we have to go through, right? We have to learn new things. We have to figure out how everything gets connected. And most importantly, there are a lot of decisions that need to be made. And so today, what I'm going to show and talk about is a project that I actually worked on for about 6 months last year to bring one implementation internally, to bring them from an internal implementation to implementation with Spring and Spring Boot. And then we had to deploy all of these things onto the Kubernetes environments and even adopting potentially multi-cloud, right? So this is the project I work on. It's for one of the alphabet companies. I cannot name which one or the name of the project, but it's pretty relevant to today's world because we're actually using and adopting many of the open source projects that everybody uses. So today the talk is going to have two sections. A lot of it is going to be the lessons learned about what we implemented, the architecture that we implemented, all the decisions that we had to make. And then hopefully towards the end, I'll show some demos on some of the tooling that I talk about and just show you how everything kind of works together, okay? So first of all, the infrastructure. Of course, we're developing against Kubernetes. So the infrastructure is the entire Kubernetes cluster. We have multiple environments. So for example, we have the developer environment where we continuously to push our application into via a Git repository and a CI/CD pipeline. And then we have higher level environments like staging, pre-prod, and production, okay? And this is what the production environment looks like. We are using just about everything that we are able to do, and we actually use them for different purposes. So for example, we have a Kubernetes cluster here. In a production setting, it will be a private cluster. What that means is that even though it's running on the cloud, there's no public IP address accessible. And all of the node, all of the VMs are on the private VPC. And then we're exposing all of the networking stuff through a few things, like for example, with the load balancer. In this case, we're using Kubernetes ingress that will then create the actual HTTP load balancer, in this case in Google Cloud Platform. And to protect some of the environments from accessing from other people who we don't want to allow access, right? We are using something called the identity-aware proxy, where we will automatically proxy off all of the access. So you need the right credential to access your app. Okay, and we do this because the application itself is actually a public application. If you're developing this on-prem, you're probably going to have all of your application running internally in a VPC, and then you as a developer can just access that environment directly from the same network. But because this is all developed on the cloud, we have to add extra layers of security so that for staging and for the testing environment, you need additional credential to access it. And then we have all of the application, the front end and the back end, deployed into a specific namespace from within Kubernetes. Right, in the single Kubernetes cluster, we can have different namespaces, so you can separate it to deploy different projects or for different teams. So for my project, for this particular project, we're deployed into a specific namespace. Okay. And then, of course, we have to access some database in the back end. However, for a lot of the monitoring and service-to-service communication for trace, for like Prometheus monitoring, for Grafana, we are managing all of these things through Istio, which is a service mesh that we lay down on the Kubernetes cluster so that we'll transparently intercept all of my requests and record all the metrics information like latency and success rates and failure rates. Okay, and then we are also using it to act as a load balancer, both for internal services, so between the front end and back end, and also for external service. So when you actually access this application, it will go through the load balancer, but then it will go through Istio ingress, where we do URL mapping, and then we send the traffic to the front end or the back end, respectively. Because everything is in a private cluster, we also have to make sure that we have some access to the external IP addresses. For this, for example, we're using some third-party services, and if the cluster is private, usually what that means is that you cannot access any public internet, right? That is a good thing because you want to restrict that access. So for us, we also had to set up like a network address translation gateway, an AT gateway, and also using Istio to control the egress of my traffic so that only certain external services can be accessed and some of them cannot be, right? A lot of them will be blacklisted, for example. Okay, so that's the overall architecture of the application. And as you can see, in a production environment, things get quite complicated. Okay, and one of the first things that we learned is that the team initially set up all of these things by using a console, right? So they went to a cloud console and start to click around, right, and to create a cluster, to write some configuration, to deploy them, and all of these things are just command lines or the console. And one of the biggest gap is that later, when we had to produce a second environment, of course, it was very difficult to remember for anybody to remember what configuration they actually have produced. And so even before we started to replicate this environment, we realized this issue. And so the issue is really that if you're doing ClickOps, which is what a lot of developers like to do, right? It's really easy to get started to try something out. When you productionize it, you actually have to turn all of these commands and clicks into GitOps. So you want to be able to reproduce your environment very, very easily and predictively, right? And so what happened then is that we are then turned everything that we created, that we learned how to do as a POC, we turned everything into Terraform. Right? So we're using Terraform, for example, to recreate the entire environment. We're using Terraform to create all the networking stack, the VPCs, the load balancers, and also the Kubernetes cluster. And we're also using Terraform to lay down all the basic facilities like Istio of the service mesh, so that when everything is created, when the environment is created, all we have to do is to deploy our application into the namespace. And that is the level that we are able to achieve. And this has been tremendously helpful. And so that when we're reproducing the environment from dev to staging to prod, all we have to do is to modify the Terraform script by updating some attributes in terms of how many nodes or how much capacity do I actually need. But every time that we try to reproduce my Kubernetes cluster, it will prepare the namespace so that I can actually deploy. Okay. Let's see. Now, for the local development, though, it's a very different story, right? Because this is the things that we can do in the cloud. But for local development, what we learned very quickly is that local development is not production. Okay, and there are many, many reasons for it. In the production environment, we have to lock everything down. It's a very secure environment. We have to deal with all of this setup with the VPCs, with the load balancers, with the SQL database that's production level, right? With the Istio configuration that is production level. And if you want to put all of these things similarly into your local environment, you might actually need a very big machine. For example, to deploy Istio or all of these other things into your local environment setup, you have to increase the amount of memory and the CPU so that you can actually run everything in the local Kubernetes cluster. What we found is that for local development, we really want to focus on the productivity of the developers and focus on the design of the application. And actually, you don't really have to start with Kubernetes. That's number one, right? So it's counterintuitive, but when you want to deploy and create your application that will ultimately go into Kubernetes, don't start with Kubernetes. And the reason for that is that your application should be really thought through in terms of how you design it. And in most cases, you want to follow the 12-factor app design patterns. And I have asked quite a few people about 12-factor apps in my previous talks. And surprisingly, a lot of people still haven't heard about it. And even for the people who heard about it, they don't actually implement any of the factors. Well, that's not true. Actually, you should always implement at least one factor because one of the first factor in a 12-factor app is checking your code, right? So everyone should actually have your code in the revision control. But in addition to this, you should also be able to configure your app from externally from your application, right? So for example, for a lot of the folks who are using like the new frameworks or even the older applications, we tend to put our configuration into a properties file, and then that file gets bundled up in the jar. And then if I need to change any configurations, I have to rebuild the jar, right? So the first thing is to figure out a way to extrapolate that. And then the other things that it talks about here, for example, is building stateless applications. Make sure your processes are stateless and make sure that you can scale out by scaling out your application, right? So many of these things are concepts that we're going to visit within Kubernetes over and over again. So the first thing is that to make sure that your application is actually 12-factor. Another reason for it is because that, today we're using Kubernetes, for example, but in the past, we might be using just VMs, or we might be using another platform as a service. And tomorrow, we do not know what that platform may be. But regardless of the platform, your app mostly remains the same if you follow these best practices. Another thing that we are able to do is to make sure that all of our tests are running locally. Okay, so when we're running these applications, even though we ultimately deploy into a Kubernetes environment, we still want to make sure that we can run our application locally, or that we can run our unit tests and integration tests locally. Okay, and there are two different things. Running your application locally might require you to spin up some databases and or other dependencies, and you can spin this up in an environment like Kubernetes, and then you can test and do a rough run around your application to test everything out. But for unit testing specifically, you need to make sure that the tests are reproducible. If there are any flaky tests, you need to fix them. And in most cases, you may actually need to test against external resources. So for example, for our application, we're using PostgreSQL. And to test against PostgreSQL, you either have to keep an instance up and running, or you can spin up a PostgreSQL container as part of your test process. And the best way to do this is actually using a project called test containers. And so I'm going to switch over to my example here, where I do have a little Spring Boot application, just for example. And I am actually, let me get rid of that. So in this case, I'm using a Spring Data JPA. I have a person repository here. And this is connected up using Postgres. Let me zoom in a little bit because people may not be able to see it. Okay, but for testing purposes, what I have done is to create a test case using something called test container. So with test container, this can actually hook into your unit testing cycle and being able to start a container, in this case like Postgres, or you can start another container, any container you want as a dependency. And when your test, before your test starts, we'll start a container for you. And then you can run the test against the container that we started. And then you can, at the end of the test, it will spin down the container. So that every time you run the test, this will create a new container that actually has the state, the initial state that you're looking for. Okay. So once you added the dependency, in this case, what I have done here is just follow through some of the documentations, and you can annotate the test with the test containers annotation so that it becomes part of the hooks into the lifecycle. And then with the add container annotation here, this marks this API, this creation of PostgreSQL container. This will actually hook into the lifecycle so that at the starting of the test, we will actually go out and create this container for you. Okay, so test container will do this. And they do have different containers you can use. Some of them are pre-made so that you have these easier to access methods. So for example, for the PostgreSQL container, I can just give it the PostgreSQL container image I want to use. I can configure the username and password and the name of the database I want to initialize. And at the start of the test, I can also configure the data source, and I can get the gRPC URL and the username and password directly from this container instance. So I don't now have to hard code any of these configuration. And then I can then just run my test, right? And again, at the end of this test, the container will be spun down. And you can do this with Redis, with other microservices. One of the best thing to do here, of course, is that if you are calling out to another service, make a container, for example, or make a stub for those other services so that you can spin them up and make these calls as part of the integration test or as part of your unit testing. Okay. So being able to run everything locally is absolutely important in this case. And once we have decided on the architecture, one of the first questions that everybody asks about starting a new project, regardless of whether you're developing with Kubernetes or not, is whether you go with Mono Repo or multi-repo. Okay, there's one of the first questions, first challenge that we have to face. Okay, because we're creating microservices application, which one do you choose? Well, it really depends. Well, it depends on whether you're building a distributed monolith or a distributed service. But it's actually a little bit more than that. It really depends on the maturity of the team and also the structure of the team. Okay, there's really no right answer here, right? Even if we talk about distributed monolith or distributed service in terms of mono repo or multi-repo, the real decision-making point here is that we know that we want to create distributed services. Okay, but if we use a mono repo, then we are effectively tying our release lifecycle with the repository, with everything that's in the repository. So if I change one of the services, I will have to release another service as well. Okay, that's the nature of mono repo, but it's also because of the tooling, right? Because with mono repo, potentially we just have a single CI/CD pipeline, and when we do the build, we build it from the top, and we build everything in one shot. Okay, with multi-repo, on the other hand, you can potentially build individual repositories, but the downside of that is now you need to have multiple CI/CD pipelines. Okay, and then if you think about that, then you have more and more things that you have to manage. Similarly, in mono repo, you can share libraries very, very easily. In a multi-repo, you would actually have to have proper infrastructure, like a Maven repository, to push out your dependencies, and then so other people can pick up these changes, right? So now you have to manage a Maven repository. If you don't have it already, that's new things you have to manage. Okay, and similarly, with a team, if you only have like 3 people in the team, multi-repo with a couple of services, that can be really hard to manage. And mono repo is a lot easier if you think about it. With 3 people working on the mono repo, you can still get the benefits of a distributed service in terms of scaling, even though not with the velocity or lifecycle. But it is definitely much, much easier to get started with a mono repo than a multi-repo, right? So there's a lot of pros and cons. And one of the things that we always do in the projects is that we write down the pros and cons, and we weigh out the options, and we have to make a decision. Okay, and we actually decided to go with Mono Repo because it was definitely a lot easier for us to ramp up. The team was really small, so we were not well equipped to be able to manage multiple repositories, and we didn't have the right infrastructures for the Maven repositories or anything else, right? And we are also needing to set up the first CI/CD pipeline, and we gotta get at least one right before we can even consider other ones. So we chose Mono Repo for a good reason. However, the other thing about making that decision is that we always have to anticipate change, because we know that we will outgrow this mono repository. We know that one day we will have to split it up. So if you anticipate for this change, then you will design your application properly. You will design the repository properly so that later you can actually split it out. And so we actually have been able to successfully do it. And the repository structure looks something like this. We're using Gradle for this particular project. So all of the services, they have their own individual directories here, and they all inherit a common Gradle file for the build. So all of our microservices are built exactly the same way. So that later, if we do need to split it out, we can just take one of these directories that's already self-contained, and they can still refer to the common Gradle files that we are using for the common build instructions. Okay. Yeah. So this is an example of the use of the common.gradle. So one of the learnings here is that even before we got to Kubernetes in this case, we had to figure out what are some of the challenges here in the decisions we have to make. And mostly we have to write down a pros and cons documentation, and we have to really weigh the risk and the current reality. And then we need to anticipate change to be able to adopt and migrate in the future. Okay. For service-to-service communication, for this particular project, we're using gRPC. Now, I know a lot of people are using REST, which is also good. But we choose gRPC, which is a binary protocol, over REST, which is more of a text-based protocol, because we're Google. No. Well, gRPC is open source from Google, but we chose it not just because we're Google, but also because of the familiarity of this protocol with the team makeup, right? All the team members know how to use gRPC, but also because that we can define our payloads really, really easily with the proto file. So we can define the schema upfront with a simple proto language, and then we can then generate these objects directly for other languages. So we never actually have to write our own POJOs to map a payload into my POJO. All of the objects are automatically generated by gRPC directly. Okay, and with these proto files, of course, we also have to pick and choose where to put them, because each proto file defines a service and the payload for the service, the schema for the service, right? So this questions always come up as well, which is, where do we put the schema? Do I put all of the services schema into a single directory, or do I put individual schemas in their own individual services directory? And again, this is very similar to Mono Repo versus multi-repo. And the advice here is, again, weigh out the pros and cons. Your situation may be different, but for us, we know that we wanted to, even though we're using a Mono Repo, we still want to separate out the services. So all of our services are designed to be self-encapsulating, so that we decided to put all of these schemas directly together with the service, right? So each individual services not only has its own build that they inherit, but also the proto definitions for the schema as well. Okay, and then you can actually bundle up these schemas as a jar file as well, and then you can share these jar files with other consumers as well. So if I'm consuming your service, all I need is to get your proto file that you put on as a jar. I can actually take that jar, I can look inside, I can get that proto file, and I can use it to generate the object so that I can interact with your service as well. And finally, with gRPC, because it is a binary protocol, to expose this to the web, most of the browsers don't actually speak HTTP2, so we actually have to do additional transcoding between the web HTTP protocol into gRPC. And you need to do this potentially via a proxy. Okay, so for local development, we're just using a simple Envoy proxy to do this. But then because Envoy proxies actually has gRPC-Web transcoding built in, you can use other things as well. There are other additional proxies you can use. But for non-local development, we're using Istio Service Mesh. With Istio, it can actually transcode gRPC-Web into gRPC backends, so that I actually don't need to do this in my app. I do not need to run additional proxy. But we're also using Istio for many other purposes, like traffic routing, load balancing, egress whitelisting, circuit breaking, and mutual TLS as well. Okay. Now, I'm going to skip out a little bit here. We understand the architecture, we understand some of the things that we chose to use, and we understand the process on how to make those decisions. Now let's get into containers. Okay, our app runs locally, which is awesome, and I can run all the tests locally. And now I'm ready to build this container. Now there are many, many ways for you to build a container. Most commonly, people write a Dockerfile. And this is what usually what I see. Oh, let me go back to the console. So typically, when you want to create a container, a lot of people create a Dockerfile here, and then you would have to choose a base image. So for example, OpenJDK 8, something like that, and then you need to copy your artifact, which is the jar file, right? Like star.jar into some directory here, app.jar. And then you run the entry point, and you say java-jar, and then the app.jar, right? And you save it, you do Docker build, and you ship it, and now this is in production. That is actually really bad, okay? So one of the things, there are many, many issues here. I'm gonna dive into the issues, and I'll show you the easiest way to do this. First of all, the from image, OpenJDK 8. What specific version of OpenJDK 8 is this? Well, that depends on what's already on your computer. If you already loaded OpenJDK 8 from 2 years ago, it could be OpenJDK 8.8U142. If you never pull the newer images, you could be stuck on that old image for all you know. You actually don't know what the exact images are. And this is the first point. One of the things that we also observe is that you need to use a right OpenJDK version. Because in a containerized world where you do need to deploy into Kubernetes and containers, the OpenJDK version actually makes a huge difference. If you're using an older version of OpenJDK, so in this case, I'm gonna zoom in a little bit. Oh, zoom in. Okay, so here I'm doing a Docker run. I'm gonna limit the CPU to 1, and I'm gonna limit the memory to 256 megabytes. And I'm going to use the older version of the OpenJDK, which is 8U141. And I'm going to print out the flags. And tell you what, I'm going to go show you the max heap, right? So even though my memory is limited to 256 megabytes, my max heap that's automatically inferred by the JDK is actually significantly bigger. So what is this number right here? So I'm going to use Perl. I don't know if anyone's seen Perl recently. So I'm going to use Perl here. As a calculator. So I'm going to divide it by 124, so that's 1K, and that's 1 megabyte, and one more, and that's gigabyte. So the max heap is actually being set to about 2 gigabytes right now. That is significantly more than 256 megabyte that you allowed it for the container. And the thing is that if you exceed this limit, your JVM will crash, or Docker will kill your process, and it will give you this OM killed message, okay? And with 2 gigabytes of heap, it's really easy to go over 256 megabytes of memory restriction. Similarly, if you look at the thread as well, so I'm going to say grep for the thread. Let me see, maybe it's threads. Even for the parallel GC thread here, what happened is that the older OpenJDK version, they do not know how to infer that you are actually running with the equivalent of one core, one CPU. So what this will do in both cases is that they actually went to the host and they got the amount of memory from the host and the amount of CPU from the host, and then they calculated the max heap from there, and then calculated the number of threads that you need from there. Okay, and this is dangerous because your application might very well overuse the resources that you are allowed it for. Similarly, well, if you are to use the newer version of the JDK, let me say AUAA, and if you go ahead and look at it max heap, that is actually a more proper number. So if I do the calculation here again, that's 124 in megabytes. That's just about 126 megabytes of max heap that's allocated for 256 megabyte of Docker container memory that you can actually use. Okay, so very important to understand what JDK version that you need to use. The second part of it is that this jar file can be very big, and also there is no security. We haven't really added any of the other optimization in here, and there are so many things that we can do to optimize this Docker image. Don't run as root, create a smaller image, learn how to layer. So one of my friends and also a developer advocate, Matt Rabel, who works at Okta, he once said, because it's a security company, they do authentication. He once said famously that friends don't let friends write authentication. And that's important because, first of all, it's repetitive. You always do this at first, and it takes a lot of time, and it's error prone. And why do it when you can, choose a service? Well, I then learned that what I say is friends don't let friends write Dockerfile. So don't write your Dockerfile because it can be complicated, and there are many ways to create a container without using a Dockerfile. My current favorite is Gib, which is an open source project that we are actually using in our own internal project as well. And what this will do is to allow you to add a plugin here for either Gradle or Maven. Okay, and all I need to do is to add this Gib plugin, and then I can configure what I want in it. So for example, it will automatically give you a base image to use. But if you want to use something specific, because you should always know what version you're using, then you can specify the from image. And then if you want to specify the user so that you don't run as root when you start your JVM, you can also specify the user there. So definitely do not run your application as root. You should always configure this as well. And once you have done this, then what we can do is go back to the console and can do a compile. I'm going to do skip test, the skip test. And then I'm going to do git build. And what this will do is to effectively analyze what's in your build file, whether it's Gradle or Maven. We will automatically figure out what layers to create so that the libraries goes into one layer and your classes goes into a separate layer, so that later when you do need to change your application or make modifications, if you don't modify your dependency, we can just simply switch out the layer that has changed. And mostly for your classes, the layers are very, very small. In this case, I did a git build, and it actually built directly into my remote repository. Okay, and if you don't have a remote registry, if you want to just work on this in a local environment, then you can do git docker build, and this will actually create the same container image, but also just built into your local Docker daemon. Okay, so for our cases, right, for my project where we are doing a lot of the development locally, we are using Git, and we're also pushing these container images potentially to the local Docker daemon as well. Okay. Okay, I'm going to skip a little bit here, skip ahead. Now, for the local development, for what we have learned is that, well, in addition to the test, you do actually want to be able to run the whole application yourself so that you can see and roughly go to the app and test all the UIs and everything end-to-end together. We actually started out with something called with Docker Compose, so that we can start the application container, the front-end container, and also the Postgres container, and so on and so forth. It was really, really easy to start. However, it differed just a little bit too much from Kubernetes because we did want the developer to learn about Kubernetes and to be able to adapt to for example, the YAML files that you have to create and manage. And so we later switched over to another tool called Skaffold. Okay, and we also had to decide on what we use for the local Kubernetes cluster. There are a number of choices here. So, for example, if you're running on Linux, my favorite so far is called K3s. With K3s, you can simply copy one of their command lines. Let me see if I can find their thing very easily. K3s.io. Yeah. If you're running Linux, you can simply copy this command line if you trust it. Right? You can copy it, and it's true. In about 30 seconds, you do get a Kubernetes node up and running, and now you have a local Kubernetes cluster that you can use and deploy your application into Kubernetes very, very easily. It's really, really awesome. However, when we were using it, there were some missing features. So we ended up using Kind, which is another project. Kind really stands for Kubernetes in Docker. So if you have a Docker daemon, you can just run Kind, and it will spin up Kubernetes inside of Docker. That's amazing. And then it runs Docker images, right? And you run this in the cloud, which also runs in containers. Anyways, so you can use Kind. You can run Kubernetes in Docker. That's super cool. And then you can also use this for integration testing too. So if you ever need to run a full end-to-end integration testing with Kubernetes, you can actually spin up Kubernetes cluster as part of your testing script using Kind. But I'm actually using a Mac. So I'm using Docker for Desktop or Minikube. Either one of them are really, really good. And then you do need to create your YAML files for your application, and you will store that directly with your services as well. And just like we don't want you to write a Dockerfile, there are also ways for you to not to having to write YAML files. So in this case, we can create a YAML file directly from the command line. So something like kubectl create deployment, and then you run it with a --dry run or OYAML, and it will generate and output the YAML file in std out, and you can just pipe it into a directory, and that is one of the easiest way to do this. Now, I recently also discovered another really nice tool, and it's called Decorate. Okay, so if I go back to the console, I always need to remember where to go. There's another project here called Decorate right here. You can check out their sites, decorate.io. What this will do is to automatically, in this case, I'm using Spring, so it's going to automatically inspect my Spring configuration. And then, as part of the build, so if I come back here and say maven-d skip test, clean and package, and as part of the build, Decorate is a annotation processor, and what this will do is to actually generate the YAML file for you. So this is actually really, really neat if you're just trying to get started. So I'm going to open up this generated YAML file. Oh, let me see here. It's in target, test classes, meta, decorate, Kubernetes YAML, this one. So here you can actually see the actual deployment that Decorate generated. And down here you can see all the different configuration that they added. Let me find this other one. So let me grab for YAML. Oh, target classes, not FUD. Let's see. There we go. So here's the target classes meta-inf. Here's another one. This is the actual one I would really want to look at. So for this one, this is the actual deployment. And if I scroll down a little bit, because I'm using Spring Boot Actuator, Decorate actually understands this configuration. So it went ahead and also configured my liveness probe and my readiness probe for me, and configured them to point to the right locations as well. Okay, so that's another really, really easy way to not having to write some YAML file to begin with, and you can enhance it later if you know what you want to modify. Okay. Finally, for the running of the app in this local Kubernetes cluster, once you have all the YAML files, rather than using Docker Compose as what we started off with the Kubernetes files, we're now using something called Scaffold. Okay, and with Scaffold, it allows you to basically do this development cycle really, really easily. So, for example, here I have a Scaffold file. And you can generate this file. If you're using IntelliJ or VS Code, you can generate this file by using a plugin called Cloud Code from Google. And you can just go ahead and say Kubernetes, and you can add Kubernetes support. Okay, and once you add Kubernetes support, it will automatically introspect your pom.xml or build.gradle file. And then if it discovers JIT, it's going to go ahead and generate this block for you so that we know that this is building my project with JIT, and this is the content image that I want to create too. Okay, and then it's also going to automatically discover the manifest. So the files that we just created, like the demo.yaml or the Kubernetes.yaml, it will be automatically discovered, and it will be added to this manifest. And in addition to this, you can now just run Skaffold dev, and we'll start up what we call a development loop. And this is what we do also in this project, which is that you can actually, this loop will actually create the container for you. It will deploy into Kubernetes, and it will watch for changes. Okay, and every time that you change a piece of code, it will recompile your app, rebuild the container image, and then do the redeployment for you. Okay. So for example, in this case, I'm going to use Cloud Code again. I'm going to do this thing called develop on Kubernetes. I'm going to just go ahead and run it. Okay. So let's see if this works. I'm going to go ahead and start my app. And this is going to read the Skaffold.yaml file. Okay. And then it's going to go into the manifest directory, which is KIS, and deploy my demo.yaml in PostgreSQL because I'm using database backend here. Okay, and then we'll just have to wait for this to start. So for example, if I go back to my command line and see get pod, I can see that my applications are just waiting to be started. Okay, we can also browse my cluster from the right. So there's a little Kubernetes cluster panel here, and we can go ahead and see what's here. So I'm running in Minikube, and here's my namespace, and I can go into my workload. And I can see the pod, and this is the Postgres pod, and this is the demo application pod, okay? And I can hopefully stream the logs, and I can see that my application is up and running right now, okay? That's pretty neat. But then if I go back to the run, I should be able to see my application up and running, right here. And once everything's healthy, I'm going to see that log being streamed as well. Okay. And what this will also do, there we go. Yeah, so we have the logs being streamed. What this will also do is to set up a pull forward, because I'm running this application in Kubernetes. So this Kubernetes cluster could be in the VM. It could also be remote. So if I want to see this application, I will have to have access to that cluster and then to expose that application on a port. And Scaffold will do this automatically by setting up this pull forward right here, so that right now, if I go to my localhost 8080, rather than going to my app, if I want to run this locally, right? Rather than doing that, it's actually going to forward the traffic into Kubernetes, into this particular application. And so I can test this application out as if it was running locally. So if I go to localhost 8080, like that, and this application response is actually coming from the application running inside of Kubernetes. Okay, it appears as it's local, but it's actually running in Kubernetes. Similarly, if I were to make a code change here, say hello Java, so I'm going to create a little controller here that responds to the hello URL. I'm just going to do a save. And Scaffold and Cloud Code is going to realize this change, okay? And it's going to rerun the Docker build command, or in this case, using JIT, okay? And then once the container has been created, it's going to go ahead and redeploy. So it really takes out the repetitive cycles of you doing this manually. This just automates this whole development cycle automatically, okay? If you want, sometimes this is useful, you can also just do a debugging session. So you can actually debug your app as if it was running locally. This will actually automatically create the debugger port for you and connecting to that debugger port, even if your application is running remote on a Kubernetes cluster for testing purposes. Okay. So now we have the application redeployed, and the port forward has been reestablished. So now I should be able to go ahead and run my application again. Hopefully this coming back up. This usually takes some time to reconcile a little bit. There we go. Whew, that was close. And then I should be able to see my change. Hello, name is equal to Ray. Like that. And now I can see my changes reflected directly in the cluster. So this is a really nice way if you ever need to test everything out in a real environment locally. But if you do see something you want to change quickly, you can do this, and it will automatically redeploy your app accordingly. But of course, you would always want to go back and update your test cases, rewrite your test cases, so that you can do the test even without Kubernetes as well. Okay. So let me go back to my slide here. I think I'm almost done. There's just one last note about the liveness probe and the readiness probe. This is most important. If I go back to my code here, now remember, sorry, I'm having a lot of trouble finding my IDE. So we actually have configured two of these things. So in this application, because I'm using Decorate and the actuator, it automatically configured the liveness probe for me. This probe, if you fail it, if this endpoint ever fails with this threshold in this amount of seconds and stuff like that, Kubernetes will actually try to restart your application. Okay, so we'll try to recover your app, thinking that a restart will help. Okay, now think about the situation where that actually is the case, right? So for example, a lot of us have a JVM restarted every week because they run out of memory, something like that, right? But is that the root cause of the problem? Can it be fixed by restarting your app? In the case of memory usages, yes, you can fix it by restarting the app, but it's not the root cause of the issue, right? Because you really need to go back to your app and figure out why it is running out of memory. So use the liveness probe accordingly and smartly, and make sure that whatever that endpoint that you check on is something that you can actually recover from. And one of the things you really need to watch out for here is that you don't want to check the health and fail this check if the database fails, right? So for example, if your application depends on the database and the database had a failure, and then you fail the liveness check, then Kubernetes will restart your app, thinking that restarting the app will recover the problem. But the true cause of this is your database. So no matter how many times your app restarts, your database is still down, and this will cause problems with your other apps. So for example, if you have another backend that depends on your backend, and it also fails because your backend fails, right? And then now they are getting restarted too, and now you will have cascading failure. Now your entire infrastructure is going to be restarting over and over again, and that is not a good thing. So you need to be able to think about how do you implement liveness probes and readiness probe smartly, okay? So I think that's pretty much all the time that I have. Last note here, just that the road to production, it's long. It's not always easy. And for developers, you may be involved in some of these decisions, whereas a lot of people may not, right? And so for the local development, we really want to focus on the productivity and the simplicity of getting the app to work, right? And follow the best practices so that they can be packaged up and deployed into the environments. And the road to production, there are many, many more things to think about in addition to security policies and just hardening the whole environment. Okay. So with all that said, thank you so much for being here. I hope that was useful, and I hope that you learned some of the ideas of how we make all of our decisions, and also many of the tools that we used, and maybe you saw some of the demos that could be interesting for you as well. And with that, thank you so much for being here.